Today's lesson will be about factorising monic quadratic expressions. Quadratic expressions are those which contain an x squared, and they may contain an x to the power of 1, and they may even contain a term that has no x in it as well. They also have coefficients on the x squared and the x. These coefficients here are labelled a and b. The term by itself is labelled c. Monic quadratic expressions are expressions where the a is equal to 1. Now, before we can have a look at factorising monic quadratic expressions, it's important to go back and have a look at expanding brackets, and in this case 2 brackets, because what we're doing when we're factorising is we're going to be working backwards. So when we're expanding brackets, we make sure we multiply everything in the first bracket by everything in the second bracket. Once we've done that, we collect the like terms, in this case the 5x and the 4x, that gives us 9x. Now, what we're going to do is work back the other way. This is what factorising is. So what we're going to do is we're going to start with the expression that we finished with, x squared plus 9x plus 20. Now, the 20 came from 4 times by 5, and the 9x came from collecting the 4x and the 5x. So when we're working backwards, we're going to split the 9x up into 5x and 4x. Once we've done that, we're going to factorise by grouping the pairs, pulling out the common factor of x in the first bit and pulling out the common factor of 4 in the second bit. And then we're going to factorise the brackets by putting the common bracket out the front and the terms that are left over in the second bracket. If you have a look, the brackets that we've ended up with after factorising are the same brackets that we started out with when we started expanding. Expanding brackets and factorising are opposite operations. Let's have a look at a quick example. If we start with the monic quadratic expression x squared plus 10x plus 24, first of all, the a is equal to 1, the b is 10, and the c is 24. So we're trying to find two numbers that multiply to give the 24 and add to give the 10. So let's try some pairs. 8 and 3 multiply to give 24, but they don't add to give 10, so that's wrong. 12 and 2, no, they don't quite work either. How about 6 and 4? They multiply to give 24, and they also add to give 10, so they're the numbers we're looking for. We split the middle term up into those two numbers, so 10x becomes 6x plus 4x. Once we've split the middle term, we're going to group by factorise by grouping, So we factorise each of the pairs. Once we've done that, we've got 2 brackets that are the same. That bracket goes out the front, and the terms that are left over go in the second bracket. We've just factorised the expression x squared plus 10x plus 24. Let's have a look at the steps that we've used there. So we've used 4 steps to factorise that monic quadratic expression. The first step was to find 2 numbers which multiply to give the last term, c, and then also add to give the middle coefficient, b. The second step we did was to split the middle term up into these 2 numbers. Once we've done that, we've factorised by grouping, and the last step was to factorise the brackets. Let's try another example. Okay, so in this example we have x squared plus 2x minus 35. So the a in this case is 1, the b is 2, the c is negative 35. So we're trying to find 2 numbers that multiply to equal negative 35 and add to give 2. Negative 7 times 5, that's negative 35. But when you add those two numbers together, they don't equal positive 2, so that can't be right. Let's try it the other way around. 7 times minus 5 and 7 plus negative 5. Yes, that equals the right number, so that's good. So we split the middle term up into 7 and negative 5. So 2x becomes 7x and minus 5x. Then we factorize by grouping each of the pairs. We pull out the common factor and we get left with two brackets which are exactly the same. That means we're allowed to factorize the brackets. Put the common bracket out the front, and in the second bracket put the terms that are left over. So we've just factorized the expression x squared plus 2x minus 35. Let's try another example. So we have x squared minus 13x plus 42. So the a in this case is 1, the b is negative 13, and the c is 42. So we need to find two numbers which multiply to give 42 and add to give negative 13. I know that 7 and 6 multiply to give 42, but they don't add to give negative 13. But if I tried negative 7 and negative 6, that works. So I'm going to split negative 13 up into negative 7 and negative 6. Once I've done that, I factorize by grouping the pairs, pulling out the common factor, putting it at the front. I get left with two brackets which are exactly the same. I put the common bracket out the front and put the terms that are left over inside the second bracket. I've just factorized our initial expression. Now, just to recap, let's have a look at those 4 steps to factorizing Monic quadratic success. First of all, we have to find two numbers which multiply to give the last term c and add to give the middle coefficient b. Secondly, we have to split the middle term up into these two numbers. Then we factorize by grouping the pairs. And lastly, we factorize the brackets. If we can remember these 4 steps, factorizing Monic quadratic expressions isn't all that difficult. The other thing that we should remember is that factorizing is just doing the opposite of expanding brackets. All we're doing is working backwards. If we can remember our 4 steps for factorizing, all we're doing is working backwards to put our expression back into brackets.